Hi, in this video, I'd like to go ahead and introduce 2D pockets in Mastercam. So on the screen right now, you'll see that I have an actual part that I modeled up in SolidWorks, and it's really just to demonstrate what we're shooting for in Mastercam. So I'm going to stick with our very simple parts here. Are using our stock material that is 4 inches across, 2 inches in this direction, and 1 inch thick, and just add a pocket to it, a very simple pocket that we'll do in Mastercam, where this pocket is 3 inches, 3 inch dimension in this direction, 1 inch dimension in this direction, and is 0.6 inches deep. So again, just a very simple part to get the mechanics down of actually doing pockets in Mastercam. And you'll also notice if if you happen to be watching this and you're not one of my current or former students who are looking at this for current instruction for class or as a refresher, you'll notice that I've got some sharp corners in here. And what I'll do is talk about that at the end of this video, but also do additional videos where we make some changes and talk about the radiuses that are left behind by tooling. So just want to call your attention to that again in case you're watching this and you don't happen to be one of my current or former students who are watching it. So let me go over to Mastercam here. And so what I'm going to do is instead of taking the SolidWorks model that I have and bringing that into Mastercam, I'm just going to go ahead and redraw this as just a two-dimensional drawing in Mastercam, and then go ahead and do the tool paths from it. So once again, with trying to do something that's fairly simple here, I still want to be able to show how to draw things in Mastercam, even though if you get into more complex parts, it may not be the thing, particularly for my students, it may not be the thing that they would want to do. They may want to use SolidWorks, but I'll address bringing in a SolidWorks part and working with that in an upcoming video. So at any rate, what I'm going to do is I'm going to go ahead and first draw the rectangle that defines the outside of my stock part. So it's really with what I'm doing in class here. The other thing that I've mentioned to my students is that for the purposes of this class and what we're machining with these small plastic blocks, we are making our stock piece and our finished part the same exact dimensions. So although that's not necessarily how it would always happen in industry, or even for them when they get to their senior projects and have to use that may not be always the case for these introductory videos. That's sort of what I'm sticking to. And once again, there will be another video that coming up where I will give some strategies for using parts or using stock material that's bigger than the finished part. So I'm going to go ahead and anchor this to the center for this rectangle. And when it tells me to select a base point, I'm going to go ahead and select the origin here. So I'm going to make this, again, this outside rectangle be my 4-inch by 2-inch rectangle. Instead of completely getting out of this particular command, what I'm going to do here is I'm going to make use of this OK and create new operation over here in the rectangle dialog box, and just go ahead and make myself a new rectangle inside that will represent the pocket. So this happens to be 3 inches wide and 1 inch in height. And I'll just go ahead and select OK. And so now I have the geometry that I've created, which is the representation of the outside of the pocket, or essentially what we use as the contour for the pocket, as well as the outside of the part here. So at this point, what I'm going to do is, even though the geometry is quite simple, I'm going to go ahead and save this part. So I'm going to go do a file, save as, and go right to where it is that I'm saving. And in this case, I'm just going to save this as pocket 1 and hit save. So another thing that I want to mention about these videos is in the first sets of videos, especially with the contour, I made these in a lot shorter sessions, but that was so that I could break it apart into more discrete tasks within Mastercam. At this point, though, if I'll go through a lot of the same tasks in terms of doing the machine setup, the stock setup, but I'll try to stick to doing it all in one video for the most part, and maybe break it out a little bit as if it gets to be that I think it's getting to be a little bit too long. But that's sort of my intention right now. So the next thing that I want to do now is I want to come in and add my machine group. So I'm going to choose my machine. So from this machine tab, I'm going to come all the way over here to the left, and I'm going to choose the mill that I'm going to choose is this one that I had already added in previous videos, which is this generic Haas 3X mill. And I'm going to select it, and you'll see that over here in my toolpath manager, of course, the machine group pops up. I'm going to also open up the properties here for this generic Haas 3X 3-axis VMC, and I'm going to make some changes to my tool settings and my stock setup that you'll see are going to be very familiar to you from the previous videos that I had done with the contour. So in this case, I'm going to warn of duplicate tool numbers, and I'm going to set up these, override these defaults with modal values, and just go ahead and enable each of these. Once again, from the last one of the last videos I had mentioned, if you ever have a question about what it is that these settings are doing, you can always open up the in context help. It will launch in a separate web browser, and then you can usually select on parameters. And when the parameters opens up, you can see an explanation of what these different settings are. So in my stock setup, I'm also going to enable this display, and I want to have the wireframe display because that happens to be what I prefer. I'm also going to go ahead and put my dimensions in. There's an easy way to do this. So what I'm going to do here is I'm going to select all entities, and you can see what happens is I then wind up with my 2 inches in my Y direction and my 4 inches in my X direction. And my stock part, again, this is the representation of the chunk of material that I'm going to be cutting. So what I'm going to enter in here is my 1 inch. The last thing that I'm going to do in here is I'm going to move my, simply left click over here in this corner so that I can move where my stock origin is at. And you'll see once I'm back out onto the screen here, I will also move the origin for my geometry as well. So let me just go ahead and select OK and do that. And you'll see that because right now my origin for my geometry is, in the center here, these two don't match up the way that I would like them to match up. So what I'm going to do here is go into the transform tab, and I'm going to use this move to origin. And it tells me to select the point to translate from. So what I'm going to do is select this lower left-hand corner, and it just moves everything over. Just to review, if you want to clear these colors back to the original geometry colors that you are using, you can go in here to the Home tab, and in this Attributes group, there is this button called Clear Colors, and it will bring everything back. If you want to view things, things that on the screen a little bit better and sort of get everything to fit in the window, in the View tab, I can go over here to where it says Fit, and it will zoom and fit to the entire window. If you don't really care for that, you can always use your mouse wheel to zoom in and out. And you can also hold down the Shift key and move the center, hold down the center mouse wheel, and you can sort of pan around. So now that I have my machine group in here, I'm actually going to go in and add my toolpath. So I'm going to add in my pocket toolpath. And so just to again review here, I'm not using these 3D toolpaths. I'm using still these 2D toolpaths over here. So in order to find that pocket, I need to expand this gallery simply by left clicking on these arrows here. And that opens things up, and I can see that I've got a 2D pocket that I can choose. So I'm going to go ahead and do that. And the first thing that opens up here is my chaining dialog box. So in this case, in the last video or in the contour videos, what I ended up using was this single chaining method. What I'm going to use here, though, is this default chaining method, because what I want to do is select this entire area to chain, so this entire inside area. So if I simply left click on this now, what happens is you'll see the entire rectangle is highlighted. You'll also see that this is the direction that the tooling will take around this as well. But what we're going to end up doing is setting up a zigzag toolpath. So at any rate, let me go ahead and select OK here. And it launches me into this 2D toolpaths for pocket dialog box. So very similar looking to the contour that we did. And so the first thing that we're going to do here is we're actually going to select our tool. So we're going to select the same tool. We're going to use that 1/2 inch flat end mill. So a lot of this is also going to be very similar to what we did in terms of going through the filter, selecting the library tool, and then changing our feeds and speeds. So that's what I'm going to do now. Let me go ahead and just kind of review how to use this filter. Right now, the only tool that I have selected is this flat end mill. So if I want to, or if you happen to open this up and all of these tools are selected, you can actually left click on none and it will take all of these away. And what you can then do is just go back and select the thing that you want, which in this case for me is this flat end mill. And I want to find the Mastercam library tool that is equal to a 1/2 inch in tool diameter. So I'm set here, and so I'm going to go ahead and select OK. And by the way, this has a drop down here. So what I've done is I've taken, and in this drop down, I've just set this to equal, and then manually entered in my 0.5 inches. I'm not going to change any of these other settings right now. I'm just going to go ahead and select OK. But you'll see that, again, by using this filter, it does not change any of the tool name or anything here. I actually have to go into this tool library and select my 1/2 inch flat end mill. So I'm going to go ahead and select the 1/2 inch flat end mill. And you're going to see also that now I have this tool number in here for the tool number, the length offset, and the diameter offset. What I'm going to do is, because I don't have this same tool number loaded on the milling machine that's in our lab, I'm going to go ahead and change this to the number that I do, which is tool number 6. So that's the tool number associated with that tool. That's the position that it's always in on the mill. That, if you'll notice, that also changes the length offset and the diameter offset. And we want that to happen because all of these settings in here will eventually trigger different G codes to be set whenever we go to post-process. And we really need the tool number, length offset, and diameter offset all to agree, so that when we go and run this on the machine, we don't have any bad things happening. And I'll talk about length offset and diameter offset in class a little bit more. So the other thing that I want to do here is I also want to change this feed rate. We're going to use the same feed rate that we used before for the contour, which is the 20 inches per minute. And we're going to use a spindle speed of 2,500 inches per, or 2,500, RPM, so revolutions per minute. So again, the feed rate is in inches per minute. The spindle speed is in RPM. So I'm also going to make this my plunge rate. So the plunge rate is actually the rate at which the cutter is plunging into or entering into the material. The feed rate is the rate at which the material is being fed into the cutter during the cuts. So at this point, what I'm going to do is just make this the exact same as the feed rate. And over here in the retract rate, so this is the rate at which the cutter is actually coming up out of the material at the end of the cuts, I'm going to enable this rapid retract. So the rapid retract in this case, what that does is that's going to move that, it's going to tell that milling machine to move at its most rapid rate, setting a G00 code in whenever we post process. And again, with the G codes, I'll talk a lot more about that in class as opposed to in these videos. I'm going to also add a comment in here, just a simple comment that this cuts a pocket. And again, these comments will also be output into the G code as well. I'm going to go down here to my cut parameters, and in this, I'm going to leave the climb, the machining direction at climb, and we'll discuss climb versus conventional milling in class as well. The other thing that I'm going to do down here is I'm going to set the stock to leave on walls and the stock to leave on floors at 0. So in other words, I'm going to take everything off in this pocket. So if you desire to leave stock on the walls or the floors for additional finishing passes or something like that, this is a way to do that. But for the purposes of this class, we're going to go ahead and take this all the way down to 0, which means we're not going to leave any of the material on in terms of the depth or along the side walls of the pocket. So I'm going to step down to roughing now. In this one, the only thing I'm going to change is I'm going to change to a zigzag roughing method, zigzag cutting method. So this is what this is going to do, is going to drive the cutter back and forth. So instead of using a high speed or some of the other cutting techniques here, I'm going to use a simple zigzag, and I'm going to leave all of these other things, including the step over percentage and distance, set to their current defaults. For the entry motion, so when I move down to the entry motion, what I want to do here is make sure that my helix entry motion is enabled. So the reason that we use the helix, and we can, you can turn this off and just plunge right into the material, or you can use a ramp where it just kind of ramps, into the material. But I do like the helix. The helix is nice for plunging into the material in the middle, sort of to start the cutting in the pocket, because what it really does is it takes advantage of the end mill's side cutting capability. So the end mills are really designed for side cutting, not for just plunging into material. Now we use in our labs, we use predominantly center cutting end mills, and so they can plunge directly into the material, but this does make for a more efficient cut, which is why I like to use it. And I'll go ahead and just keep all of the rest of these defaults set the way they are for now. So for our finishing cuts, I'm just going to do one finishing pass here. And what I like to do in here is I like to enable keeping the tool down. And I also like to make sure that machine finish passes only at final depth and machine finish passes after roughing all pockets are enabled, specifically for this class. So these are a couple of things that will actually end up cutting down on the amount of time that we spend machining. Although you're going to see that, for this particular part, it's really the actual machining time does not take that long. In fact, for most of the parts that we do in class, the machining time is not what takes up the most time. It's actually the setup of the machine in terms of homing the part and things like that. Especially when you're new at trying to find all the buttons and stuff like that. So the next item down on the list here is the lead in, lead out. So for the lead in, lead out for this, I'm actually going to disable that for this pocket. So I don't really need this. So I'm going to be just going over to the part. I'm going to be plunging in using that helix entry method. And so I really don't have a need for the lead in, lead out, because I don't really have any sort of complex setup that I need to avoid clamps or anything like that. I am going to enable the depth cuts. So for the depth cuts here, what I'm going to do is enable a max rough step of 0.2. So this is pretty similar to what we did with the contour. You're going to see that whenever we go to cut this pocket, or when we simulate the pocket, it's going to divide this into 3 equal parts. And the reason is that we're going to be setting a final milling depth of 0.6 here down at the linking parameters. So I'm not going to change anything else in here. I'm not going to be adding any finish cuts or anything. Let me just skip over the breakthrough. We're not breaking through this material. So remember, the stock material is 1 inch thick. So in this case, what we're actually doing is we're just going to be milling down to a final milling depth of 0.6 inches. So we don't need to enable this breakthrough. So I'm going to go ahead, jump to my linking parameters, and go ahead and set all the typical things that I set in here. So I like to set this clearance, and I also like to make sure that all of these are set to absolute. So again, we're using absolute versus incremental moves in the class, such that all of the moves that are made by the machine, once we generate the G code and put it on the machine, all the moves will be based on moving from our origin, not from a previous tooling position. So that's what we're looking to do. The final thing that I want to set in here is the depth, and I'm going to make this a negative 0.6. And just as a reminder, the reason that I set this as a negative number here is because this is the top of my stock and my depth is below that. So right now, this is in the Z direction, this is my 0. Anything below it, in order to machine this pocket, is going to be at a negative depth. So let me go ahead and select OK to this. And you're going to see now, as I go out to the screen and I hit my view button and go to my isometric view, you'll see the toolpath. Okay, so now you'll see that this thing is, it's going to be plunging in here. And we're also going to see that this is indeed using the depth cuts here. So you can see that this is divided into three different steps. The one thing that you'll kind of notice here, though, is that because this is such a small pocket, we actually don't have room for the cutter to go in a helix motion. So that's why you're not seeing that replicated in these tool paths right now. So another reminder here is that whenever so basically what's going to happen is this is going to plunge in here and zigzag back and forth. Another reminder here is that if as you add more tool paths, which we'll be doing in upcoming videos, if you want to make sure that these tool paths do not display on here, there's actually this toggle that you can use. So right between over here in the toolpath manager, right between the lock and the little ghost looking icon, there are these toggle display icon, little wavy lines that you can do, and to show those and to hide those as well. So what I want to do now is let's just go ahead and run the simulation, and we'll kind of see what's going on here. So I'm going to run this, just kind of step this all the way through. And again, what's going on here is because this is such a short distance here, we're not actually getting to take advantage of that helix entry motion. So it just it just plunges into the material. So, and that's okay, because again, what we do in the labs is we end up using those center cutting end mills, and so plunging into the material is not that big of a deal. So let me just, instead of stepping through this, I'm just going to finish this off. And the reason that I want to do this is just to kind of point out something that I'm going to address in an upcoming video, and that's the idea of these corners. So you can see my geometry that I drew here kept these very sharp corners, but that's not something that is typical for machining anyway. Very, very rarely do we want very sharp corners unless there's some functional design reason to do so. But no matter what you specify here in terms of corners, you have to realize that whenever you're machining, you're always going to be at the mercy of the radius of the smallest cutter that you use. So in an upcoming video, right now, what's happening here is this is the smallest radius that we can get into this corner with, because we're using a 1/2 inch flat end mill. So the only way to really address this is if we use smaller cutters, or if we use something like pocket remachining with a smaller cutter. So in upcoming videos, I will kind of address that and talk to you about some strategies for making these corners better. But from a design perspective, again, there would not be too many reasons to leave those sharp corners unless in your mechanical design there's some reason to have those from a functional standpoint. So anyway, until the next video, I hope you enjoyed this one, and I hope you found it helpful, for stepping along with as well. Thanks.